As we begin our new unit on writing classes, I wanted to do two things. One, review vocabulary that we introduced in Unit 2, and also introduce you to how we build classes. So, the first thing you want to do when you write a class is you want to figure out what the name of the class is. Now, Java is object-oriented programming language, which means that you can think of objects that are either concrete or abstract. So, for example, dog, cat, mailbox, or something a little bit more abstract, such as ideas that are nouns themselves. Today, I'm going to write something called the date class. So, like the date today, the date tomorrow, whatever, like whatever the calendar says it is. I'm going to write a class that encapsulates basically the information for any date. So the first thing I want to do is I want to write the word public and then the word class, and then I want to name the class. Now you'll notice with my class name, I capitalize it. That's convention. It's not Java's rules, but it is something that is agreed upon for people to easily identify. And I'm going to open and close my braces. Now that technically is a class definition, and I can save my class, and then I can compile it, and it compiles because I basically haven't broken any rules of the language. I haven't open and closing braces. But you'll notice when I click run, nothing happens, and the reason is when we click run, we are running the main method, and you'll notice that there is no main method. So I'm going to create a separate Java file, and I'm going to call this one test date. Now, could I write a main method inside my original one? Sure. I'm just not going to, so that way you can see that really the tester class is trying it out or is going to use it or implement it in some way. So here's where I'm going to write my main method. And I'm going to save this, and again, it should compile because I haven't broken any rules of the language to my knowledge. All right, so what am I going to do? Well, I have this date class, and it's really boring. It's really empty, right? There's nothing happening in there. But technically, I've done enough where I can create a date object. And the way I do that is I invoke the dates constructor. Now you'll say, wait a minute, I don't see a constructor in here. And the answer is you're right, there is no constructor. When you do not write a constructor, there is a default constructor provided for you. So I'm going to create a date object. Now remember, a class is a template for an object. From the class, we can make as few or as many objects that we want. So I'm going to create one date object using the default constructor. And the way I do that is I specify that I'm going to create a date object. I'm going to call it, let's say, D1 equals new date. The word new is the word that will create the object. And then I'm going to put parentheses and a semicolon, and when I press compile, it compiles fine. When I click run, nothing happens because, again, you'll notice in my date class, there's really nothing going on there. Okay, so I created a date object using a default constructor, but that is kind of pointless because there's nothing going on. So let's go back to our date class and make something of this. Now, what is the purpose of a class? The purpose of a class is to encapsulate in a pretty little package all of the attributes and behaviors of that object. Attributes. All right, let's talk about those first. We can call those instance variables. So attributes, properties, fields. Think of all those as synonyms. So we have instance variables. Now, what do we have about a date? Well, a date, just to keep it simple, has a month, a day, and a year. So for my instance variables, I'm going to list them. And the way I'm going to list them is I'm going to first say the word private. Now, let's talk about keeping our data protected. When we have our attributes, we want to keep our attributes private. Anything that's private is only accessible in that class. So these instance variables, I'm only going to be able to use inside this class, period. That's it, right? Okay, so let's go ahead and I'm going to say private. And so month, day, and year are going to be ints. So I'm just going to say private int month. And I could do this on one line, but I'm not going to. There you go. So now I have three attributes. Now, interestingly, something important that you need to keep in mind is that instance variables are specific to each object. So every time I create a date object, theoretically, the values for month, day, and year can vary, and they can be specific to that particular object. So like today's date, tomorrow's date, a date from 3 weeks from now, all of those will have their own values. Or theoretically, again, they could have the same data values. But these are specific to each time you create an object. It's the data for that object. All right, so now let's go back to our constructor. So right now, nothing exciting is happening here. I'm going to keep it that way for a second. And I'm going to create a method that I'm going to delete later on. I'm going to call this public string return data. And just so you can, or actually I'm going to make this a void, just so you can see what's going on here. So print data. All right, so what I'm going to do is, I totally messed that part up. I'm going to just do a print line statement. I'm not going to leave this in here, but I kind of want you to see what's happening just for a second. And so I'm just going to do a print line statement that has the month, and I'll do a slash, let's just say, plus day and year. All right, so what's going on? So right now I have these three instance variables. They're attributes that I say every date is going to have a month, day, and year. Hopefully that makes sense, right? And then I have this one method called print data, and it's going to print the month, day, and the year. Now you might say to yourself, okay, well, what is the value of month? What is the value of day? What is the value of year? I'm going to get a compiler error because I haven't set any values to those. But you'll notice it doesn't give you a compiler error. Now the reason goes back to the fact that when you do not create a constructor, the compiler will create a default constructor. And what the default constructor does is it initializes all of your variables if they're primitive data to their version of 0. So like ints, it's 0, double 0.0, boolean would be false. And then if you had any reference variables like strings, it would default those to null. So, okay, so I have this. Let me go back to my test date, and I'm going to call the print data method. So to do that, I'm going to say d1.print data. And when I compile it, it compiles because I used my object and I invoked the method. And when I run it, you'll notice, just as I said, it's printing them with values of 0. So that's interesting, right? The default constructor will initialize these for you. All right, but again, that's kind of boring, right? I mean, 0, 0, 0, what in the world is that? That's not even something that makes sense. So what I can do is I can create my own constructor. The way I create my own constructors, I use the word public. Now, why do I use the word public? Because you want other people to create objects. And if you make it private, no one can use that constructor. All right, so by making it public, it means someone in another program can create a date object by using this constructor. And then I write date. The spelling has to match the name of the class identically. Notice, in this method, I use the word void. We don't even put the word void. We don't put static, we don't put void, we don't put any return type at all, or any other we just say public and then the name of the class. And then I'm going to put parentheses here. Now by doing this, you'll notice, you'll say, okay, well, there's still nothing going on in there. I'm going to call this the no argument constructor. It's kind of like a default constructor. On the user end, it's the default constructor, right? It's the one that they can use. But on my end, I'm just choosing for it to be no arguments. Now, what does that mean for my values of month, day, and year? It means that I need to make values for them. So let's say that the default value for month is going to be 1. The default value for day is going to be 1. Um, and the default year is going to be 2000, let's just say. All right, so how does that change our information? Well, I'm going to compile it. It compiles fine. That's good. I didn't make any errors in that. Let's come back over here and see what happens when I compile it and I run it. You'll notice now it says 1/1/2000. So I created a date object. It called the no argument constructor in the date class. And inside this constructor, we initialize the instance variables to be 1, 1, and 2000. All right, so far so good. So does that mean we are destined to always have a date that's 1, 1, 2000? And the answer is no, we're not destined to that. We can overload the constructor. Now, when we overload the constructor, what we are doing is we are making another constructor, except this constructor is going to use a different number of parameters. All right, so I can say public date. And this time, let's say someone's going to pass us a month, a day, and I'm just going to call it M, D, and Y. All right, so what does that mean? Well, it means that someone's going to tell me what the month value is. Someone's going to tell me what the day value is. Someone's going to tell me what the year value is. And so now it's on me to assign it to my instance variables. Okay, well, my instance variables are month, day, and year. And what are they going to be passed? Well, hopefully they're going to be passed in this order, right? And so that means that month is going to get the first parameter value, M, day is going to get the second parameter value, D, and Y is going to get the third parameter value, Y. All right, so now let's compile it, and it still compiles fine, and let's come over to test date, and now let's make another date object. Now in this one, rather than pass it nothing, I'm going to pass it 3 values. So I'm recording this on January 3rd, 2021. So that's what I'm going to pass it, is those 3 values. So to represent the month, I'm going to say 1. To represent the date, I'm going to press 3. And for the year, I'm going to say 2021. And because this is going to be a date object, it also has access to the print data method. And so I'm going to say d2.print data. And when I compile this, it compiles fine, except for the fact I didn't put an equal sign. All right, now it should compile fine. And then when I run it, you'll notice it precisely says what I assign the values to. Now remember, that order matters. Now in the United States, we do month, day, and year. Let's say we were in a different country that writes their dates with day, month, year. And so let's say I'm in a different country and I do this, you'll notice it doesn't differentiate. If I think this means January 3rd, 2021, it's not going to, it's going to say in our mind that it's 3/1/2021. It may not seem like it now. You're like, well, that makes sense if someone thinks to write it like that. But later on, if I'm trying to calculate what the day is or the month is or the year is, that's where it is. So even though this may look like, okay, well, that's how other countries might write it, it wouldn't be true for other values that, or calculations that I might do. All right. So we have 2 constructors. I have my no argument constructor and I have an overloaded constructor. I don't have to have a no argument constructor. Sometimes it doesn't make sense to initialize values to generic values. And in that case, I'm just going to comment this out. You'll notice I just now have the one constructor, and so this will compile fine in date class, but if I come over to test date and I compile it, I'm going to get an error. And the reason is that there is no longer, because I commented it out, there is no longer a constructor that accepts no arguments. It requires 3 ints, right? And so you'll get a compiler error. But I'm going to leave that in there just for our sake. So we have a no argument constructor and we have an overloaded constructor, and really I can make more I could accept a string that represents like the final version, and then I could extract the digits and assign that. But that's above where we went. All right. So what do we have in our class? Well, we have our public class and the class name. We have our instance variables. We have whatever constructors we want. Remember, the purpose of the constructors is to determine how people can create objects, and the values that are passed as parameters then get assigned to your instance variables. So the whole point of the constructor is to initialize your instance variables. All right. You'll notice though that this information is private. I can have public constructors, and I have this one method, which I'm not going to keep forever. I'm just going to put that in there for right now. Actually, let's go ahead and get rid of it. I'm going to get rid of it because I want us to learn something else. All right. So let's say I get rid of this. We don't really, I mean, you might have print line statements in your class, but really the goal is for it to not use system.out.println. It wants to use its own internal forces. So we're going to now write some methods. Now, the first type of method I'm going to teach you is an accessor method. We call these getters. Now, the purpose of an accessor method, well, this information is private, right? No one can access it from outside of the class. If I were to come to my test date and I were to try to print D2 dot month, because D2 has a month, you'll notice I get an error that says it has private access. The fix is not to make these public. In fact, on the AP exam, you should not be making these public. Instead, you make public methods that give permission to the user to access the information. And so let's say I wanted to access my month. So what I'm going to do is I'm going to say public int. Now the reason why I'm saying int is because month is an int, and so if I'm going to give access to the data, I'm giving access to an int. And you'll notice that my variable's name is month, and so I'm going to call this get month. And then I'm going to put parentheses at the end and open it up. This is a pretty simple, straightforward method. All I'm going to do is return my month. Okay, and then I'm going to write two other accessor methods for get day. And here I'm going to return the day, and I'm going to get year. And I'm going to return the year. Okay, so this is a way for you to provide access to the data indirectly. No one's actually looking to see what the data is here. They don't have the ability to see what that memory is, but you are giving them essentially a copy of what's stored in there. And so you'll notice here, now I can't say d2.month, but I can say d2.getMonth. I can call the method that's giving me access, and when I do that, it'll print the month, which was January. So those are accessor methods. They're getters. They get you access to what the data is indirectly. We also have another type of method called mutator method. These are called setters. Now, mutator methods allow you to indirectly modify your instance variables. And so the way a mutator method works is we say public void, because we're not going to return anything back. We're just going to input information and use that information. And now let's make something called set month. Now for this, I'm going to set the month to be whatever they pass it to be. Now let's talk about scope of a variable for a second. This variable m is going to be a local variable specific to this method. This m is not the same as the one that's up here. In my constructor, this variable m existed from the start of the constructor to the end of the curly braces, which means it is safe for me to reuse that variable. Month, day, and year are global variables to this object. Essentially, anywhere in this, I can use those variables. but here it's safe to reuse M. And so I'm going to say that I'm going to assign month to be whatever's passed to me. And that's pretty much all you have to do for a setter. And I can create one for set day, where day gets assigned the parameter value. Notice the order is important. This has to be your instance variable. This is your parameter value. If you switch it around, you're changing your parameter value, not your instance variable. And then basically when this is done, no changes have been made. All right, I'm going to do one more for set year, and I'm going to assign that. So now I have the ability to indirectly update my instance variables. And so when I compile this, I'm good. So you'll notice here, so I have this date D1, and I'm using the default constructor. So if I were to do a print line statement where I said D1 dot get month, and let me just copy paste that, D1 dot get day, get year. And I compile this and I run it, you'll notice that the month, day, and year for up here was 1/1/2000. Okay, and so now what I can do is I can modify the variables. So I can set my month to be whatever it is. So let's just set it to June 12th. All right. So I'm going to set month to 6, and I'm going to set the day to 12, and I'm going to leave the year alone. So notice I'm using 2 of them, but I'm not using all of them. And now I want to see what the values are, so I'm just going to copy and paste that. All right, so when I run it, you'll notice that the first 3 represent the original values of D1's month, day, and year. And then I change the month and the day, and so these values represent the new month, day, and year. And then this last one just represents the month of D2. Okay, so we have this general structure that we're building. We name our class. You list any instance variables by saying private, their data type, and the name of the variable. You create your constructors. You can have as few or as many as you need, but the whole goal is to assign initial values for your instance variables. When you have parameters, those parameters get assigned to your instance variables. Because our instance variables are private, we provide indirect access through our getters where we return the data. Now, side note, you might not want access to provide access for all of these. So if I didn't want someone to know a particular information, let's say like a password, I might keep that getter. I might not write a getter for that. And then we can also provide access for people to modify our instance variables. And likewise, it might not make sense for you to always provide access for modifications. Now, this is kind of boring, but it is the general structure, and we can do a lot more with these classes. I'm going to show you 2 last things before I'm done with this, or maybe 3 things. Let's say I did something like, and let me comment these out. Or just a comment. I don't think I have the updated one where I could just do that. All right, that's okay. And I'm going to comment these out. All right. And this, because I don't want to see those print lines. Let's say I wanted to do a print line statement, and I do something like system.out.println D1. All right. When I do this, you'll notice you get some sort of weird garbly goopy thing. It's like there's some hexadecimal digits and you have the name of the class. Think of this as like, where is that object stored in memory? Well, that's not super useful. what we can do is we can write a method called toString. Now the toString method over overrides the version in the objects class. Now what is the object class? The object class, think of it as like the granddaddy of them all. It's the source of everything, right? It has some built-in stuff from which you can build on in all these other classes. And when we get into talking about inheritance, you'll learn about how you can extend classes. Every class ultimately extends the object class. Now in the object class, we have something called a toString, and you'll notice I'm saying override versus overload. When we override, we are replacing the version in a parent class, in this case the object class. So if we want to write a toString method, I have to be very careful of how I write it. I say public, I say string, and then I say toString with open close. I cannot change the spelling of toString. If I mess up on my capitalization, it's essentially creating an entirely different method unrelated to this one. I have to return a string. Now, what happens in a toString method? Well, it's kind of up to you or your program requirements. Think of it as visualizing your object's data in a readable format. So what would that look like for a date? It's pretty simple. Think of it as what would you put in a print line to see your data, except you're not using print line, you're saying return, and you're building the string. So think of it like this. Let's see. If I return the month plus a forward slash as a string plus the day plus the year, what is that going to do for me? So it should compile okay. Let's come over to test date. Now, remember, I am printing D1, which means this is implicitly calling D1.toString. All right, so when I do that, you'll notice it prints it in the format that I expected. And remember, I had changed the month and the day. ToString, again, is a way of visualizing your instance data as a string. Do you always need a toString? No, it doesn't necessarily make sense to see everything as a string, but it is a way also for you to kind of check your individual variables. If I wanted to, instead of saying all my accessors, which you should still have, but instead of having to call them individually in my test data, I can call it if it is putting it together in some sort of readable. The last method I want to talk about is called the equals method. How can we compare two objects? Well, just like how we have a version in the object class that we want to override, this will override the version in the object class as well. And you'll see that it's very specific. Now, you might say to yourself, well, why am I saying object if we're in a date class? And again, you have to do it this way to replace the version that's existing. Otherwise, you're basically making your own version. All right, so the first thing I want to do is I want to take this parameter and I want to cast it to a date. So I'm going to say date, D, let's say, equals, and the way I cast it is I say date in parentheses, just like we would cast to an int, we can cast to objects, other. And now I can use D to do whatever I want. So what does it mean for two dates to be equal? Well, for two dates to be equal, they should have the same month, same day, and same year. And so I want to return a Boolean that decides if the months, the days, and the years are the same. Now think of this as we are inside a date object. You don't know what date object you're inside of, but you're inside of one. And so this date object has a month, a day, and a year. And I can see if this date object has a month that is equal to the other one that we casted to D, their month. Now, because D is a date, and because we are inside the date, I am allowed to say D.month. And again, it comes down to the fact that it's private to the date class. This is part of the date class, so this has access to it. All right, so we can decide if the month that we're comparing against is equal to the other month, and the days are the same, and the years are the same. And if so, it's going to return true. If not, it's going to return false. All right, so let's compile this. Now, instead of month, I could have said get month. That's fine as well. But because, like I said, we are inside the date class, the date object does have access to its data inside the date class. All right, so let's come over here, and I'm going to create two dates. I'm going to change this one to say 6/12. Let's say 2000, because I think that's what the other one is. All right, so let's see if the dates are the same. And so I'm going to say system.out.println so I can see my results. Let's see, does D1 equal D2? Now, hopefully the answer is true, because I think I set it up right. All right, it's true. If I were to change this to say 2021, and I were to compile it and run it, you would get false, because it's checking are all three corresponding pieces equal. And so that's our equals class. Now, I've gone over a ton of stuff, but look at this really quick. Basic structure. You write your class, public class, whatever. You have your instance variables that are private. You create however many constructors you need, and you initialize your instance variables inside your constructor. You make accessors to give indirect access to your instance variables. You make setters to provide indirect access to modifying them. And then we have this toString that gives us a string representation, where we basically take our instance data and imagine it as a string, and then we can compare objects against the other. One final thing, I promise, just one last thing. We have this word called this. Think of this as like me, I. So inside this object has a month, day, and year. You'll notice how I chose to use different variables that my parameter compared to my instance variable. What if I had chosen to say month, day, and year? Because I might say, you know what, that's much clearer for the user. Then what I can do is I can assign month, day, and year to be that. But to specify that I'm talking about the instance variables, I just put the word this dot, and this dot. And this expression, this dot month, is referring to the instance variable month, whereas month is referring to the parameter month. This dot day is referring to the instance variable day. Day is referencing the parameter. Also, for clarity, down here, I could have said this dot month is equal to d dot get month, or I'm going to change that back just to say month. So that way you're saying it might make more sense in your brain based on what you're used to thinking about. You say an object dot something. The object, when we're inside the class, is referenced by this. Whenever we say this, we mean that the current object, it's a kind of an abstract idea, but like I like to think of it as like, okay, if I am equal to the other thing, so inside my brain, I'm having these thoughts. And likewise here, it doesn't necessarily change anything other than some people like to do it for clarity, or some people like to do it so that way their parameters and their instance variables can have matching names. That's a ton of information, but What you really need to take away is this general class structure. Class name, you have your instance variables that are private, you do your constructors, you have your accessors, your mutators, you can have toString equals. I can write a ton more methods as well. It would just make my video longer. Watch this, try it out yourself, try the one that I'm suggesting, and see how it goes. I bet you can do it.